Sixth grade science class, we're cruising into lesson 3 today, talking about what are compounds and mixtures. We spent the end of last week talking about the elements and the periodic table and what we know about atoms to elements. Today we're going to take those elements and move them to the next thing, which is can we put them together in different things. When we put them together chemically, they're called compounds. When we put them together physically, they're called mixtures, and we'll spend the next 2 days talking about compounds and mixtures. So we're going to learn what they are. The summary statement says this: elements combine in exact ratios to form compounds. Compounds have properties that are different from the properties of the elements that make them up. Okay, that's what we're going to cover today. Tomorrow, or Monday, the substances that form mixtures do not combine in exact ratios. Substances and mixtures are going to retain their own properties. So we'll start ours with compounds today. The table salt in the picture is different from the elements you read about last week in lesson 2. Table salt is made up of more than one element. Most atoms found in nature are not found as elements, but are found in compounds. Number 1 in your notes. What's a compound? A compound is a substance composed of 2 or more elements, number 2 in your notes, that are chemically combined to form a new substance with different properties. The second blank in your notes. So guys, 2 big things you need to understand here. Number 1, they're chemically combined, and number 2, they have completely different properties once they are chemically combined. I suppose the third thing you should know is that there's 2 or more elements to make a compound. Okay, now they'll give you the example of this. Many components of your body are made of compounds. For example, water is a compound, and it makes up about 60% of your body. Other compounds called proteins make up much of your skin, your bones, your tendons, and your ligaments. Compounds also make up the membranes surrounding the cells in your body and the DNA that determines the traits you inherit. So guys, obviously there's a ton of compounds inside my body. Okay, now they were talking a little bit about table salt. If I wasn't going to my example here, table salt is a compound, so is water, guys. So the second paragraph talked about water. So number 3 in my notes, table salt and water are examples of compounds. Okay, and then they're going to talk a little bit about this water compound here. You had got an example of the explosiveness of this last Friday when we were dropping potassium into water and it was exploding. It's the same thing that happens with sodium, guys. You drop sodium in with water, it mixes violently with what it gives off here. Okay, we'll read about it on this page though. Each particle of a compound is made up of exactly the same ratio of elements. Number 4 in your notes. For example, every particle of table salts contains 1 atom of sodium combined with 1 atom of chlorine. So if you remember last week, if you remember last lesson when we talked about sodium chloride, that's table salt, guys. You could look up sodium and get its chemical formula that we're going to talk about, Na, and then Cl. It's always on a 1-to-1 ratio. Each particle of water is made of 2 atoms of hydrogen and 1 atom of oxygen. We're a little bit more familiar with that. Some of you might have heard, what's water? H2O. Okay, why H2O? Because hydrogen is H and it has 2 of them, and O is oxygen, and there's only 1 of them. The properties of a compound different from the properties of the elements that form it. Number 5 in your notes. For example, sodium chlorine and the sodium chloride they form have very different properties. You might be surprised to learn that the element chlorine is actually a greenish yellow poisonous gas. Now guys, when I think of the word chlorine, I always think chlorine they put in a swimming pool. But why do they put chlorine in a swimming pool? Now guys, they pour chlorine in the swimming pool. I thought they called it a gas here, but when they pour the chlorine, guys, it's other chemicals as it as well. But the chlorine in there kills things. So maybe it shouldn't surprise me that it's poisonous, right? Okay. When sodium, which is a silvery white metal, combines with chlorine, it forms sodium chloride. You eat sodium chloride every day, it's called table salt. Table salt has completely different properties. It's not a poisonous gas, right? It's not a metal that I'm eating. It combines and has completely unique things. So as I'm going through my notes here, guys, we said chlorine's a poisonous gas, sodium is a silvery white metal, but they combine chemically to form table salt. And so they're just trying to stress that, guys, completely different properties. And so some of us are like, I'm never eating salt again, it's poisonous. No, it's not, guys. Just like if I put salt in water, it's not going to explode on me. But sodium explodes. That doesn't matter. It has completely different properties. Okay, so that's what they're trying to stress with you as they go through that. Okay, cruising on for number 7 in our note. Scientists not only use symbols for elements, like you learned Wednesday, Thursday, they also use symbols for compounds. Every compound has its own chemical formula. So you got number 7 and 8 in your notes. A chemical formula consists of 2 parts: the symbols for the element, in other words, the letters, and the subscripts. A chemical formula contains a chemical symbol for every element that is present in the particle of the compound. The subscript tells how many atoms of each element are present. For example, the chemical formula of water is H2O. The formula tells you that water contains the elements hydrogen and oxygen. The subscript tells you that there are 2 atoms of hydrogen and 1 atom of oxygen to make water. The subscript for an element follows the element's chemical symbol. In other words, the subscript comes after it, not before it. So it's not H and then 2 O's. No, it's 2 H's and 1 O. The subscript 1 is never written in a chemical formula. If there is no subscript, then you know that there's only 1 atom present. It's kind of like when we do powers, guys. I don't ever write down, what's the number 4? Well, it's 4 to the power of 1. No, 4 to the power of 1 is just 4. Don't waste my time writing it, right? Okay, so same thing here in science class. Okay, so we're cruising through this, guys. It says the chemical formula for water is H. I didn't know how to do subscript with it, so you got H2O. This tells you there's 2 atoms of hydrogen and 1 atom of oxygen. The subscript 1 is never written in a chemical formula. So if a letter is by itself, it means that there's only 1 of those atoms present. Every capital letter, guys, starts a new element. So if I'm looking down here, it says the chemical formula for glucose, which is a sugar, is C6H12O6. Is glucose an element or a compound? Well, it's a compound, guys. Anytime there's more than 1 letter, it's a compound. If there's just 1 letter by itself, then it's an element. So if I had just C, that's carbon, that's an element. But as soon as I put them together, it's a compound. Now the question is, how many atoms make it up? Well, 6 and 12 and 6. So I would add those together and say there are 24 atoms to make up this compound from 3 different elements because there's 3 capital letters. Awesome. We'll get started on mixtures. Even though I said that it was going to be more tomorrow, it's mainly today, I suppose. We'll talk more about solutions, a type of mixture, tomorrow. Elements and compounds are 2 ways matter can be classified. You know that elements contain 1 type of atom. Compounds are made of 2 or more atoms combined in a fixed ratio. They're always the same. Matter that cannot be classified as an element or a compound is usually considered a mixture. That's number 11 in your notes. What's a mixture? A mixture is a combination of substances in which the atoms of a substances are not chemically combined. Number 12 in your notes. Therefore, they must be physically combined. Mixtures can be a combination of elements, compounds, or both. 13 in your notes. Look at the picture on the next page to see how elements and compounds make up sand, a mixture. So guys, I said at the end here, I'll go to this. It's a good thing. Okay, another important truth that they're going to spell out to you using this little analogy here. Substances in a mixture retain their own properties. For example, the vegetable soup in the picture contains chicken, noodles, celery, carrots, other vegetables. The vegetables are separate and can be easily identified. The components of a mixture do not have a definite ratio. One bowl of soup may have more carrots than the other bowl. Okay, so remember, in a compound, Like the last thing we looked at, glucose, it was C6H12O6. It always has to be 612,6. If it's not, then it's not glucose, guys. Okay, this is always chicken noodle soup here. But if I give you a bowl of chicken noodle soup, you might have 1, 2, 3, 4, 5, 6, 7, 8 pieces of chicken in it. Give the next kid a bowl of chicken noodle soup. It might only have 5. The next one might have 12. It's different. It's still chicken noodle soup, guys, but it's not the exact same numbers. Okay? So that's key one. That they maintain their own properties. And then number 16, they are not in a definite ratio. Next thing you need to know, mixtures can also be easily separated. Now guys, I wrote down mixtures can be separated. We're going to talk about the word easily. In some cases, yes, it's easily. And in some cases, I would say, nope, it's definitely not that easy to separate those things. So they're going to say, let's go back to this one. I don't like carrots. Can I pick out the carrots? Yes. Is that easily separated? Well, I can easily see the carrots, but I don't know how easy it is to pick each and every one of those out. Okay, now if I have big chunks of carrots, that becomes easy. I make really small pieces of carrots, it starts to become a headache, doesn't it? So I took the word easily out of there, guys. What they're saying is you're supposed to be able to identify it, but let's talk about it. If you don't like the carrots in the soup, you could easily pick them out. Some mixtures are more difficult to separate because the components are very small. How do you separate a mixture if you have a smaller components? What happens if I mix salt? I took a piece of iron and I shaved it down. Those are iron filings. So really small pieces of filings. So think of salt, think of iron, the same size as salt, the same size as sand. In other words, what aren't you going to do? You're not going to pick those out by hand, are you? That would take you forever. But they said it's supposed to be easily separated. So, can it be separated? Sure. Mixtures can be separated using the physical properties of the substance that it contains. For example, the iron filings in your salt iron sand mixture are magnetic. So I could separate them using a magnet. So I grab my big pile of mixture here of sand, salt, iron, run a magnet over it, whoop, pulls all the iron out of it. Now what remains is just salt and sand. Now if I add water to the sand salt mixture, the salt will dissolve in the water. Then I'm going to pour that water, salt, sand mixture through filter paper. The sand will collect on the filter paper. Sweet. So now all I have left is a salty water mixture. And all I have to do is evaporate all the water off over some hot kettle and the salt will remain. Okay, I hope you can see why I took the word easily out of it. Can we do it? Yes, guys, you can do it. Okay, using the physical properties that it contains, I can do that. Is that easy? No, I don't know how many of you, number one, why we would care to separate those things together. But point being this is, I'm not gonna run a magnet, add water, mix it all together, run it through filter paper, then evaporate out. It can be done if I had to do it, but it's not easy. Okay, so they're talking about filters can be used to it. It catches larger particles. The smaller water particles would fit through your filter paper there. Even coffee, guys, can be separated from water by evaporation. Okay, coffee is a mixture, guys, but we'll talk tomorrow how coffee is a special type of mixture called a solution. Just going back over here, the first day's lesson 2, elements. One kind of atom will have a chemical symbol. Like carbon would be C, oxygen would be O, calcium might be Ca. Can't be divided into anything simpler. Calcium is calcium is calcium. Review number 2 from today, compounds. It has to have 2 or more elements. So it's not going to have a chemical symbol, guys. It's going to have a chemical formula containing chemical symbols, but also might be containing numbers. Okay, so a formula puts more than one together. Yes, it can be broken down into simpler substances. I have water. I can break it down into hydrogen and oxygen if I chemically change that. So they give you sand here, guys, quartz, seashells. They give you what is a seashell? This is the chemical compound of calcium carbonate. We put calcium and we put carbon together to get those things. This is a mixture of sand. You can see the different things in there. Okay, what's a mixture? It's made up of two or more substances. Those substances might be elements, those substances might be compounds. You see how they did that? Here are compounds. Quartz is silicon dioxide. Okay, so you have two oxygens and silicon there, calcium carbonate. So they gave you compounds there. Could also have elements in there, or it could be a combination of both. They can be separated by physical means because they're not chemically combined. Awesome. Okay, so you have those things down. Extra credit today, guys. I want you to write down this little guy right here. Quartz is silicon dioxide. That's extra credit number 1. If you want super extra credit, you go on the internet and you find the chemical formula for silicon dioxide. Remember, a chemical formula would look something like this, guys. This is a chemical formula. It will contain letters and possibly numbers. Now, it doesn't have to have numbers, guys. They don't all have numbers. Carbon monoxide is CO. Sodium chloride, NaCl, that's table salt. There's no numbers with it because it's on a 1-to-1 ratio. So I don't know the chemical formula for quartz off the top of my head, but if you want super extra credit, you look it up and you write it on the top there next to what quartz is. Have a great day.